Most logical explanation is that when she died, the Mother Abbess would have burned them, buried them, done something, because Galileo's trial was such a recent memory.
Fighting advancing blindness, and often confined to his bed, Galileo began to re-examine his own early work.
I find how much old age lessens the vividness and speed of my thinking. I now have to struggle quite hard to understand things which, when I was younger, I discovered and proved.
Forced to avoid astronomy, Galileo looked back to a time before his telescope, to his brilliant but never published research on the physics of motion.
You get this extraordinary situation that he'd made these really great discoveries in the study of motion right back in about 1604, something like that, and he'd written it up in a Latin text back then. But it's so many other exciting things happened to Galileo, he never seems to have got around to publishing it. So it was, in a way, a blessing that he was put in house arrest. He finally made him get round to writing these results up.
Galileo had spent half a lifetime trying to prove the Earth moves. Now, he would come to terms with something much more basic, the mathematics of motion itself. But motion is hard to measure.
It all happens just a bit too fast for you to see what is going on. Galileo hit on this wonderful idea of slowing down the motion. So instead of trying to watch a thing falling, he rolled balls down very gentle slopes so that the speed built up very, very slowly.
Galileo reasoned that as balls rolled down slopes, they would accelerate, just as they did in free fall, but more slowly. As a young man, Galileo had designed a very accurate inclined plane, one of the most important pieces of experimental apparatus in the history of science. Galileo left behind no plans for his inclined plane, but based on his experimental notes, Professor Roberto Caparelli is using what he believes to be Galileo's original design to discover how he was able to accurately measure acceleration.
Galileo studied the inclined plane, slowing the motion of falling bodies until he was able to observe the phenomena. He was able to measure exactly how fast a ball would roll, timed with the swing of a pendulum. Galileo was sure that the steady acceleration must be governed by a mathematical rule.
So he takes this very gentle inclined plane and he lets the ball roll down and he watches how that ball speeds up and he measures how far it goes in a certain time. And then he makes his first empirical discovery that if in the first unit of time it goes 1 unit of distance, in the next unit of time it travels 3 units of distance, and in the next 5, and in the next 7. So it has this beautiful numerical progression, 1, 3, 5, 7. And he calls this the odd numbers rule. And he really is entranced by this. He knows he's made a huge discovery.
Galileo had found a mathematical rule for accurately predicting the motion of objects in the real world, a universal law which applied to any falling bodies.
Underneath this beautiful empirical law that he found a deeper law, clearly a deeper law, using mathematical logic and deductions. And this was actually the key to all the later great successes, first of Newton and then of Einstein and all the other wonders of modern science.
As a young man, Galileo had revolutionized astronomy. But at the age of 74, his last great book revolutionized the physics of motion.
From the point of view of physics, his most important contribution is his discourse on the two new sciences. Indeed, it's that book that provides the real foundation for Isaac Newton.
Within a generation, Newton had built on Galileo's work to devise a set of laws so complete that they could describe the motion of the planets in their orbits and how apples fall from trees.
It's very difficult to judge which part of Galileo's work is most important, because on one hand, he established some of the basic laws of physics. On the other hand, through his telescope, he first discovered or proved that actually the Earth is only one of the bodies of the universe. That those things we see at night are not just little flames in the sky or in the atmosphere, but they are actual bodies similar to the Earth. That there are everywhere in the universe other bodies which may be similar or different from our own, but they are our brothers and sisters in the universe.
When Galileo was a young man, most people assumed that they lived at the unmoving center of the world. Armed with his telescope, he wrote persuasively that our Earth was just one of many planets moving around the sun. The Inquisition chose to ban Galileo's dialogue, but it was powerless to ban Galileo's ideas.
I always think that his dialogue on the two great world systems was the persuasive book that made it intellectually respectable to believe in a moving world, a sun-centered universe. It was the book that won the war.
The Catholic Church long ago accepted the science of Galileo, but it was not until 1992 that a papal commission reconsidered its handling of the Galileo affair.
John Paul II said that mistakes had been made in the Galileo case and used Galileo's language to talk about the relationship between faith and reason, between religion and science.
Saying that faith should never conflict with reason, Pope John Paul II used the very words Galileo had once written in his own defense. The Pope, like Galileo, believed that the scriptures can never err, but theologians can err in their interpretation. The Pope expressed the Church's regret that the Galileo affair had contributed to a tragic mutual misunderstanding between religion and science.
By the end of the 20th century, Galileo is almost rehabilitated.
Perhaps anticipating his own revival, the old heretic had scribbled a private warning to his adversaries in his copy of the dialogue.
Take note, theologians. You run the risk of someday having to condemn as heretics those who would declare, as you do, that the earth stands still.
Galileo was right about the Earth moving, but he was wrong about the tides. Learn more about what history has shown to have been his big mistake on NOVA's website at pbs.org or America Online keyword PBS.